In this video, we will take a look at TreeMap. As you can see from the UML diagram that TreeMap is a sorted map, which ultimately extends the map interface. So apart from supporting the map methods, it supports sorting as well. What that means is that we can add entries in any order, but those entries will be stored internally in the TreeMap in their sorting order. And we can get or we can access the keys in their sorting order as well. How does the tree map sort the keys or sort the entries? If we don't provide anything to the tree map when we are creating a new tree map, then it uses the natural ordering of the keys. By natural ordering in Java, we mean that the class or the type that we are using as a key must implement the comparable interface. Additionally, what we can do while initiating a new tree map, instead of using the natural sorting, we can use a custom sorting. So in that case, we may or may not implement the comparable interface, but we'll have to provide a comparator. And if we pass a comparator, then TreeMap will use that comparator to sort the keys. So we either implement the comparable interface to apply the natural ordering, or we can pass the comparator to sort the keys as per the custom sorting. All right. If we talk about the internal implementation, then TreeMap internally uses red-black tree. The purpose of using red-black tree is to sort the keys using the underlying red-black tree, and second, to provide the guaranteed lookup performance. Because red-black tree or RB tree is a balanced tree, so no matter how many keys are we adding to this map, the internal data structure will always be balanced. And with the help of that balanced tree, TreeMap can provide a guaranteed order of log and lookup time, which is faster. Okay, so let's move on to the IntelliJ and let's see a quick demo of how we use TreeMap. To create a new TreeMap, we use the class TreeMap, then we provide the data types for key and value. So in this case, we are saying that the key is of integer type and value is of string type. Then we are using the default constructor. That means the TreeMap will use the natural sorting or natural ordering of integer, because it always uses the natural ordering on the keys, and in this case we have integer keys, so that means the entries will be sorted based on their integer keys. Additionally, what we can do, we can pass a comparator if we are interested in the custom sorting. So if we open the documentation, this is the default constructor which says that comparator is null. It means it will use the natural sorting. Then there is this constructor which accepts a comparator, so we can pass a custom comparator, and if we do that, the TreeMap will use this comparator to compare the keys and sort them. All right. Once we have the TreeMap, let's add few values to this map and let's see how it performs the sorting. So we can say 1, 3, 4, and 2. So if you notice the order of keys, it is 1, 3, 4, and 2. But if we print the map and if we run this program, we see the keys in order, in their ascending order, which means 1 followed by 2, followed by 3, followed by 4. Although we added entries in their random order, but because we are using TreeMap, these entries were stored in their sorted order. So we see 1, 2, 3, and 4. All right. Now, because TreeMap also extends the map interface, so it supports all the map operations. Everything that we learned about hash map and linked hash map applies to TreeMap as well. But in this video, we will be covering only those methods which are specific to TreeMap. So we will not be covering the usual map methods. All right. As we saw, when we added keys or entries in the random order, what TreeMap did, it basically stored them in their sorted order, in the ascending order of the keys. That is fine. Now let's say we want to reverse the order. How do we do that? Well, it's simple with TreeMap. TreeMap has a method, descending map, which returns a navigable map. That means it returns a map in the descending order. So first we get the entries in the descending order, and because it is basically a map, then we can perform the map operations on that as well. For now, what we can do, we can simply print the descending order map. To do that, we simply say, get me the descending map. All right. So if we run this code again, we see that map has been inverted. We see the entries in the reverse order. So we see 4 first, then 3, then 2, and then 1. And if we mouse over the documentation, we can see this is a navigable map. So descending map returns a new navigable map in the reverse order. And because it is a map, so we can perform further operations on this navigable map. So let's say we can say that get me the first entry, but in the reverse order. Based on this reverse order, get me the first entry, things like that. All right. So this is the descending map. This is to basically reverse the order. Because we know the entries are stored in the sorted order, so we can get the first and the last entry using the TreeMap methods. So we can say something like this, get me the first entry and a separator and get me the last entry. And if we print them, we see the first entry is 1 and the last entry is 4. So using the tree map, if we leverage the sorting, we can quickly get the first and the last entry using the first entry and last entry method. And the similar thing we can do with the descending map as well. The only difference is that it will return the first and the last based on their reverse order. So if I simply copy paste the same thing and we get the first and the last entry using descending map. So we see this time the first entry was 4 based on their reverse order. This one, this is the descending map. And the last entry was 1. So this is basically just the opposite based on their reverse order because it is the descending map. All right. Then there are a couple of interesting queries that we can perform using TreeMap. Before we do that, let me add one more entry. So we add 6. Okay. With the tree map, we can also perform ceiling and floor queries. So by ceiling, we mean if we say map dot ceiling entry. So you see this accepts a key. Now how it works is if we pass it a key, then it will return me an entry that is either equal to this key or greater than this key. So if I say get me the ceiling entry for the key 5. So what TreeMap will do, it will check if there is an existing entry with the key 5. If yes, it will return me that entry. Otherwise, it will return me the entry with key which is just greater than 5. In this case, because there is a single entry which is greater than 5, so we would see this entry on the console, 6. But if we add another entry which is greater than 5, let's say 7, this time there are 2 entries with keys greater than 5. But ceiling entry says that it will return a key value mapping associated with the least key greater than or equal to the given key. So the least key which is greater than or equal to the given key, which means it will return an entry whose key is either equal to 5 or the least key which is greater than 5. So in this case, there are 2 entries with keys greater than 5, but 6 is the least key which is greater than 5. So it will still return the entry with key 6 here. So that is the purpose of ceiling entry. Similarly, we can use floor. So we can say floor entry and pass it a key. Now floor entry says that it will return an entry with the greatest key less than or equal to the given key. All right. So if we pass the same key again, then it means it will return an entry whose key is either equal to this passed key, in this case 5. So the entry with the key 5, or the greatest entry which is less than 5. So in this case, although there are these many entries with keys less than 5, but the greatest among them is this one, 4. So this is greatest among 1, 2, 3, 4, but it is less than 5. So in the output, we will get 4. Here it is. I'm assuming you already understand the concept of ceiling and floor operations. And if you do, then you will quickly get the idea what we can do with the tree map. All right. Next, we will cover 2 more operations specific to the tree map. So let's see one by one. The first one is the head map. Head map method says that if you pass me a key, then I will return a subset of this map with all the entries whose keys are less than the key that you passed. So if we call the head map method with key 5, then it means that I want to get all the entries whose keys are less than 5. That means these 4 entries. Let's see that. So we get 1, 2, 3, 4. This is the head map. Similarly, there is tail map method, and it says that if you pass me a key, then I will return a subset of this map with keys greater than or equal to this key. Let's open the documentation. So it says returns a view of the portion of this map whose keys are greater than or equal to. Equal to if inclusive is true from this key. Okay. So let me pass the same key and let's see how many entries we get in the response. So we see 6 and 7. This is basically the subset of the underlying map of all the entries whose keys are either equal to this key or greater than this key. So 6 and 7. Now that's pretty much it on the tree map. These are the methods specific to tree map that we can use if we want the keys or the entries to be in the sorted order. Okay.